I'm going to go ahead and introduce our very first speaker here. His name is Neil Kanungo, and he's going to talk to us about storytelling gone awry, how to avoid misinterpretation in data communication. Neil is a data scientist at TIBCO Spotfire. He loves to learn and he loves to share. He has developed a passion for data analytics and uses much of his time to share knowledge with the analytics community. He has passion in data visualization, time series analysis, and geoanalytics. You can also follow him online as Dr. Spotfire. All right, I'm going to go ahead and stop sharing and bring Neil Kanungo up on our stage here. Dr. Spotfire, thank you and welcome to the DATAcated Expo.
How are you doing, Kate? Thanks for having me.
Awesome, awesome. Thank you so much for being here. I'm going to go ahead and hop off the virtual stage here and let you take it away.
All right, thanks, Kate. All right, everyone. So today I'm going to be talking about storytelling gone awry, how to avoid misinterpretation in data analysis. So my name's Neil Kanungo with TIPCO, and this is going to be just a general just general topics on what it means to be a data storyteller and what you should look out for. So as a data storyteller, you're supposed to take objective technical data and then analyze and communicate to the business for better decision making. Now, your role as a data analyst on one end of the spectrum, you can look at data. Data is often objective, factual, accurate, but it could be unappealing. It could be very dry. It could be all over the place, unstructured. It can be very unfocused. It could be difficult to interpret. On the other end of the spectrum, you have stories. They're easy to interpret. They're appealing. They're focused, but they can be subjective. They can be opinionated. They can be biased. So in the middle, we have data analysis. We have analysis, objective, factual, accurate, appealing, and so on. So with data analysis and visual analysis, there's exploration, presentation, analytics. There's many different researchers that we've talked about in the past, such as Tukey, Cleveland, Tufte, and Few worked with presentation. The analytics were done with Few and Schneiderman. They tend to focus on the science of the data. Tufte focused on the presentation of the data, and Tukey and Cleveland looked into getting the insights of the data. If you wanted to learn more about that, we did a session with Kate earlier with the DATAcated takeover in July. So you can find this on YouTube, Visual Analytics Designed for Perception Inference. So it's a great session where we go into a lot of the details of how actually these researchers and data communication, data visualization work. Now, analytics versus storytelling. Wow, analytics versus storytelling is what we're going to talk about today. How do we create the most objective perspectives? Now, as an example, there is this story. So this was from late last year, November 18th. There were some surging COVID cases in South Dakota. Unfortunately, they were surging across most of the world at the time. And in the middle of this, the South Dakota governor decided to take down mask mandates. And if you can read from that tweet, it might be a little bit small there, but what that tweet is saying is that there we go. Thanks, Kate. So they're focusing on they're going to focus on solutions that do good and not just feel good. They're going to take away their mask mandates. Now, at that time, around that time, South Dakota and North Dakota had the highest cases per capita, were higher than any single country in the world. So it was one of the hottest spots for COVID. So how could this be? And there's different levels of analysis. You have descriptive, and they vary by the value and the difficulty. Typically, the harder it is to do certain analysis, one of these analysis, it can also offer more value. So you have descriptive, what is happening? You have diagnostic, why is happening? Predictive, when will it happen? And prescriptive, what should we do about it? Unfortunately, with this situation, some steps were skipped. You went from what is happening. Well, COVID is really high, but why is it happening and when is it going to happen next? And projecting was all skipped over, and it was just gone right into what should we do? Well, we don't feel masks are working. We're going to take away the masks. Now, what was missed was multiple non-pharmaceutical interventions. So the Swiss cheese respiratory defense model, this is looking at multiple non-pharmaceutical interventions like ventilation, masks, contact tracing. All of these combined together actually create a safer environment for COVID. And this is from Nicholas Christakis, a epidemiologist that works at Yale. And so, what can we have done better? How can we have approached this any better? So some fundamental approaches is you first need to think about what problem are you trying to solve? How would you measure success? what data might be needed, what hypothesis could you be testing, how well does the data fit your hypothesis. These are certain questions you want to ask yourself in these fundamental approaches before doing your analysis. And there's things that you can answer that, which is like, what problems are you trying to solve? Well, what policies can prevent infection and hospitalization? Rather than just saying, well, our COVID cases are high, we're just going to stop wearing masks. Let's start thinking about, well, what could we actually do? And how are we going to measure that? What are we looking at to measure that? Are we going to measure by infections? Are we going to measure by hospitalizations? So there's different ways to kind of go through this and think about how we're going to do our analysis in a very objective sense. How do we look at this from very different angles? And that's the key thing, looking at it from different angles. So one thing we've done in our COVID-19 analysis, you can find this at tipco.com/COVID-19, just a small little plug there for you if you want to check this out as I'm going along with you. We looked at different interventions and when they were placed, and we kind of correlated that with cases over time. So at the bottom, you see a timeline of interventions, and these interventions are showing where restrictions were taken, the severity of those restrictions. On the top, you have the infection trend, and then on the right, you have some explanation of that to help with the storytelling, to help just we're not telling you, hey, this is why that the cases came down, but we're giving you the information you need so you can start to put this together yourself and understand the timeline of what's happening. And time is a very important factor with your storytelling. You want to know what's going to change over time, and when you have so many different interventions, how can you measure this objectively? So that's the other thing. Like, how do we keep this objective? So New York Times did a really good analysis where they looked at hospitalizations. You see cases on the left here, and then you see hospitalizations on the right here. And you have a trend of states. You have those with more restrictive containment measures, those with fewer, and you can see a trend across all of these states. Now, looking at this over time, I'm going to have a little video here. We're going to play. You can see where you have these more restrictive containment measures and less restrictive in the beginning of the spring. There was a lot of lockdown procedures, but then some states started to quickly open up after a few weeks. In June, and after a couple of months, they started opening up, and then we started to see a rise in cases. Now, this happened across the board, but we start to see it tend to happen more with places with less containment measures. And then when there's spikes in the fall, we start to really see this trend happening. So this is now going into October. Now, this is data from last year. So then we see the states with the least containment measures having the highest. Now, it's not a perfect trend. There are states with more containment measures that happen to have more cases than states with less containment measures. But you're starting to see this data from different angles and starting to see it from different trends. Now, how do we talk about going back? How do we talk about what are these containment measures? This seems very arbitrarily defined. Well, they used an Oxford University metric, which actually goes into looking at different indices, the government response indices, stringency, contact tracing, and looking at this. And so there's actually a formula there to say, hey, this is how we're defining what are containment measures and how do we measure across that. Now, we did the same type of analysis looking at vaccination. So across the x-axis, you'll see vaccinations increasing. These are all the different states in the U.S. And over time, you're seeing as the vaccinations go, the vaccinations are increasing for each state. Then it starts to pull apart where some states are continuing to vaccinate and other states are not vaccinating. That y-axis is the number of cases. And then boom, all of a sudden in late June, early July, you start to see the Delta variant coming in. That Delta variant coming in and showing you now those states with, I'm actually going to pause this right here. Those states with more vax that were most vaccinated were less susceptible to the Delta variant. They were still affected by the Delta variant, but they were less susceptible to that. So telling the story with this time component starts to allow people to kind of piece this in together for themselves. Now, changing scale and changing perception. So humans are bad at interpreting large numbers. So, this is a little bit of a heavy topic, but we want to talk about impact here, and that's what we're discussing. So here you have the number of cases or the number of fatalities per state, And if I don't know if you can totally read that, but you see in like Texas and California, you have about 65,000 deaths. That seems like a lot of deaths, but it's very difficult for us to grasp that number. If I look at this in terms of the overall, in a line chart, the overall cumulative deaths, it seems like a lot of deaths we have in the U.S. We have 600,000, over 600,000 deaths, 650,000 deaths. But how does that scale when we were looking earlier at, we had 150,000? These numbers don't totally compute for us. So here is that same table, that same map, but it's shown with different time scale. So now this is shown at a daily level. So that now daily deaths are and daily fatalities are around 308 in Texas. Now that may not sound like a lot for a state that has 29 million people. It may sound like a lot to you. It may not sound like a lot to you. We'll get to that in a second. But when we look at this again on this chart, which is the same map chart, but now this is showing the minutes between deaths, the minutes between fatalities. So now that same number here is now represented as the number of minutes between fatalities, and that's 4.67. So in less than 5 minutes, there's someone dying, unfortunately, from COVID-19 in this state, right? And we're seeing this across the U.S. on different states. So by changing these time scales to something that we can interpret more in something that's more interpretable for us, then we start to get different perceptions of these and different perceptions of the impact. So, and I invite you to kind of, write in here and comment, like, how did the changing geographical boundaries affect your perception? How did the changing time scale affect your perception? What is the right balance between the two? We also can reduce noise and bias here. So if you look at this chart on the New York Times on the left, they use a 7-day moving average. And the 7-day moving average, they have a little dip here, and that is actually a reporting anomaly from the Thanksgiving to Christmas time period. We used a different method. We used a local bivariate regression to smooth case counts, and this is actually showing that dip there is not actually modeled in our curve. So here's where you can start to use statistics and data science to help humans estimate data better. There's actually a really great example of this with Rhode Island. If you look at Rhode Island, they report once every week, and it looks like there's tons of cases, but it's really 7 times as high on those bars. And then the actual case curve is much less. You can also remove spatial bias, and we also use smoothing for this. So this is a short animation where we show that you can use smoothing bias and use smoothing to remove spatial bias, and that allows us to see hotspots. Maybe some counties are not reporting as much as neighboring counties, but if we take this in aggregate and we smooth this, then we can all of a sudden see this whole data spread without this whole data pattern without all the bias of spatial biases there. Now, Now we can model these behaviors as well. We looked at reproduction. This is and how this matters into storytelling. What we did is we looked at reproduction numbers, and why this is important is that we didn't just say, "Hey, cases are high and face masks don't work." We started looking at different angles of this. Okay, what are neighboring areas doing when we looked at our spatial bias? What are the actual trends? What are the projections of those trends? We started looking at what are the reproduction numbers and the case velocities. Here, this is actually the velocity of change of the different case growth. So not just how are the cases growing, but at what speed are they growing, and that is shown on the right here, at what speed they're growing. So by looking at this data, this is now the reproduction numbers, the number of people one person is infecting on average, and that is a leading indicator on what it might be. And for 2 weeks from now, then that starts to give us another indication. So by looking at our data in different angles, using data science, using statistical analysis, we're able to tell better stories and be more objective with our data analysis. We can also use different visual tools, such as using natural language generation, which you see here on the right. Natural language generation to tell you and explain what's happening with these very complex and sophisticated data science approaches that may not be interpretable by the layman or the average business user. We also saw these change colors because I have controls up here that show the 24-hour change. It's one thing to see where reproduction number is high and where it's low, but seeing the 24-hour change allows us to see where is it actually getting worse, where is it actually getting better. So again, changing perspectives, showing a variety of different perspectives is how we're able to look at this data. And now, wrapping up these slides here, I know we're at this DATAcated Expo. We only have a few minutes left, so we only have about a minute or so left. We used a GAMless model, generative additive model for local shape and size, and we use that for looking at the 7-day moving average compared to our super smoother that we talked about earlier, which are local bivariate method. And we have a third approach, which is a GAMless model. Now, this takes a little bit longer to compute, but you can see that it's showing us with certainty a 90% and 10% confidence levels. It's showing us something that might be a little bit different. Here, it's hard to tell. Is this going to go up or is this going to go down? But with our GAMless model, we can see a little bit better. So again, using this from different angles. So we communicate these results in a newspaper style report. You can find this at tipco.com COVID-19. There's lots of different analysis there. There's these hotspots. There's these reproduction numbers, interventions, trellising, testing, mobility, things like that. If you like this and you want to follow me, you can follow me on YouTube, LinkedIn, and Twitter. You can scan that QR code right there on your screen, and that'll actually give you a Linktree event, link that you can actually follow me and click right on my profile. But that's it for my presentation on looking at data from different angles, looking at how do we avoid misinterpretation, how do we give the audience the tools and the information they need to tell the story in the right way, to understand the stories in an objective nature.
Awesome, Neil, Dr. Spotfire, thank you so much for that amazing presentation. We do have several questions that came in. I think we have time for about 2 questions, which we will take, starting with George's question here. He's asking, what software did you use for these data visualizations?
Well, as a employee of TIPCO, I used the TIPCO, and as Dr. Spotfire, that's my little shirt. We had a Dr. Spotfire session earlier today. I used TIPCO Spotfire to do those visualizations. Some of those, I will say, were from New York Times, some of the animations, but the Delta variant animation was also in Spotfire.
Okay, yeah, thank you so much. Yeah, I'm huge on data visualization and data storytelling, and it was fascinating to see all of those visuals. An unfortunate topic, of course, but a very relevant one in the time that we're living in. We have a question on that specific topic here from Paul. You know, he says events like the pandemic are very sensitive. So how do we communicate sensitive information effectively without any misinterpretation?
I think that's a very very good question, and I will say that like what we were talking about in today's session was impact and trying to show what is the impact that we're trying to communicate and how is that relevant to the audience and the business user. Now, I believe that as scientists we need to be entirely objective, not subjective, entirely objective. And so I believe the more you can do to show that information again from different angles starts to allow people to see that you're not biased, that you're trustworthy. If you just show a few things and then you talk to people and they have, well, what about this? Well, what about that?
Yeah.
If you've answered that in other visualizations and you've answered that in different methods, then that helps people trust you and trust the topic. And it's going to be a sensitive topic. Everything's political nowadays, too. So that almost, a lot of public topics can be very political. But I think if you just stick to the data, which is what we try to do at TIPCO, we just stick to the data and stick to the science, then you let the cards lie.
Yeah, thank you. Actually, we do have time for one more question. We'll make it quick. Chandan is asking, does the TIPCO Spotfire also create interactive dashboards? Because we saw some interactivity in yours.
Yeah, it does. And I encourage you to go to tipco.com/COVID-19. You can try it for yourself. I wanted to show a little bit of that today, but we got we got a lot of speakers today. We got a quick DATAcated expo, so didn't get a chance to show that. But tipco.com/COVID-19, you can try the dashboard out for yourself and play with it.
Okay, perfect. Yeah, guys, go check that out. Neil, thank you so much for your session here today. I'll see you online. We're going to keep this data party moving.